Alrighty, this is for geometry, period 2. We're going to do a walkthrough of some of the odds. I think at some point I switch over to evens, but about half the problems on the Chapter 3 review, so you guys can get ready for the test on Thursday. Yay! Okay. So, first group, say the theorem or postulate that justifies each statement. So for number 1, what we're looking at is if 1 and 4 are congruent, then P and Q, that's these two down here, are parallel, okay? So if we're going from if the angles, then the lines are parallel, then we know that's one of our converse statements. So you should not be doing this without your little diagram of the angles and all their relations, and then also a list on your notes with all of the theorems and postulates and all that stuff. So here, 1 and 4, if we were to look in our thing, we'd see that they are corresponding angles. So it is the converse of the corresponding angles postulate. And that literally says that if two lines are crossed by a transversal and the corresponding angles are congruent, then the lines are parallel. Okay, so number 3. We're looking at 7 and 8. We look at what kind of relationship is there. We see that those are same side interior angles in between these two parallel lines right here. So, because the lines are parallel, we know that those angles are supplementary, and that is the same side. You can also call it the consecutive interior angles theorem. Remember, when we're talking about interior-exterior, we're talking about either between the two parallel lines or away from the two parallel lines. So here, this area right here would be the interior, and this area here would be the exterior. Now look at 5, 7, and 9. Notice how they're all if angle, then parallel. So we want to know, we know that each one of those is a converse. The regular postulate and theorems say if the lines are parallel, then the angles are congruent or supplementary. So if we're starting off with saying if the angles are congruent, then the lines are parallel, that's converse. So we go converse, converse, converse. And then we basically identify what the angles are, 2 and 4. 2 and 4 are alternate interior angles. So it's the converse of the alternate interior angles theorem. 3 and 8 are corresponding. So again, it's the converse of the corresponding angles postulate. And finally, 2 and 6, those are same side interior or consecutive interior, so it's the converse of the consecutive interior angles theorem. Moving on. 2 pairs of each type of angle. To make sure that I can get everything on the same page, I'm going to do 10, 11, and 12 here. Corresponding, I picked 1 and 4. They're both that top left. Picked 2 and 7, bottom right. And then I picked 6 and 8. 6 and 8, they're alternate interior angles, as are 2 and 4. Notice that it doesn't really matter which way you're going. That the alternate interior angles, that 6 and 8 are going kind of vertically, while 2 and 4 are going horizontally, but they're still alternate interior angles. Vertical angles, remember, vertical angles are the bow tie angles. You find them wherever two lines cross. And so we're going to go with 1 and 2. And 4 and 7. You could also go there, 8 and 9, 6 and 5. Okay, moving on. So in a triangle, 1, 2, and 3 are the interior angles. 4 is an exterior angle with a remote interior angles 2 and 3. So basically what this would look like is we'd have 1, 2, 3, 4. Okay, so with that, we can use our triangle interior angles theorem. And that says that the interior angles all add up to 180. Or we could use our exterior angle theorem, which says that the exterior angle is equal to the sum of the remote interior angles. So, 1, 2, 3, and 4. If we know that 2 and 3, if we're given 2 and 3, then we know that 2 plus 3 equals 4. So 4 equals 50 plus 80, or 4 equals 130. We also know that 1 plus 2 plus 3 equals 180. So we can go 1 plus 50 plus 80 equals 180. 1 plus 130 equals 180. Or 1 equals 50. We subtracted 130 from both sides. Okay, so if we know that on number 17, so we know that 1 and 3 are there, so we need to figure out angle 2. So we know that 1 plus 2 plus 3 equals 180. So we know that 2 equals 180 minus 1 plus 3. So 2 equals 180 minus 75 plus 20. Like that. So 180 minus 95, or 85. So angle 2 equals 85, and we know that 4 equals 2 plus 3, which is 85 plus 20, or 105. Number 19, kind of like number 15, we have 3 and 2 instead of 2 and 3. So we know that 4 equals 2 plus 3, 65 plus 40, 105. And we know that angle 1 equals 180 minus the sum of 2 plus 3, which in this case we know to be 105 because we just did it. So now angle 1 equals 75. Okay, number 21, a student makes the following incorrect statement. What is wrong with their statement? How do you know? If A is parallel to B and B is parallel to C, then A must be perpendicular to C. Well, we went over this and we know that if A is parallel to B and B is parallel to C, then A is parallel to C. That was, I think we call it the transitive property of parallel lines. Okay, on to the next page. So we're going to start off with number 1. So 2 pairs of parallel segments. So remember, in order to be parallel, they need to not touch as well as be in the same plane. So I can pick F and H, I and G, J and L, K and M. Now notice when I write these down, I need to make sure that I'm using the right terminology or the right writing style. So I have to put HF and then put the line over it. No arrows. Now if I just put the letters H and F, I'd actually be talking about the distance between H and F. So I want to make sure that I'm talking about line segment H and F. H and F is parallel to IG, and LJ is parallel to MK. Now, number 3, skew segments. Now, skew, the difference between skew and parallel is whether or not they're on the same plane. 2 parallel lines that are on the same plane, or 2 lines that don't touch on the same plane, are parallel. 2 lines that don't touch but aren't on the same plane are skew. So we look at that box, we have like HL and JK. Now notice, HL and JK, they're never going to touch. But they're not on the same plane. One goes up and down, one goes left to right. So they're called skew. And then I'm also going to use FG and IM. Okay? So, let's name some alternate interior, same side interior angles. I went with angle 7 and angle 6. They're on the same side of this line, and they are in between these two lines, so they are on the interior. 2 and 3 would also work. Number 7, alternate exterior angles. I picked 8 and 4 because they are on opposite sides of the transversal. That's why they're alternate. And they are not in between the two lines, exterior. Okay. Number 9, identify two pairs of supplementary angles, not including linear pairs. Well, again, this is where I would want to look at my chart that I gave you guys, that you should be looking at whenever you do anything like this, and go, okay, what kind of angle pairs are supplementary? Alternate interior? No. Alternate exterior? No. Corresponding? Vertical? Nope. Consecutive interior? Absolutely. Consecutive exterior? Yes. So, 2 and 5. Same side, interior. We also have 4 and 7. I could also do 3 and 8, 1 and 6. Okay, so then we look at number 11. If angle A is 125 and angle 1 is 5x, what is the value of x? So we look at that relationship. What is 1 and 8? What is the relationship of 1 and 8? If I said what is 1 and 8, that would be wrong. I could say what are 1 and 8. But what is the relationship between 1 and 8? And they are alternate exterior angles. And when I look at alternate exterior angles on my little sheet, I see that they are congruent. So to solve for x, I need to set 5x equal to 125. Divide both sides by 5, and I get x equals 25. Oopsie. Okay. So, state the theorem that proves A is parallel to B. Okay? So for number 13, how would I know that A is parallel to B? Well, I have these two angles right there, and the markings on those angles show me that they're congruent. So I go, okay, what is the relationship between those? Again, I want to look at my chart. I see that that is angle 2 and angle 6. When I look through, I go, okay, 2, 6, 2, 6. I'm looking for 2 and 6. Bingo, there it is. They are corresponding angles. So what is the postulate or theorem that says if a transversal crosses two lines and the corresponding angles are congruent, then the lines are parallel? Well, that is the corresponding angles postulate. Or the converse of the corresponding angles postulate. The corresponding angles postulate simply says if the lines are parallel, then corresponding angles are congruent. The converse says if the angles are congruent, then the lines are parallel. So 15, what conclusion can you make about lines X and Z based on the diagram at the right? Well, I look over at the right, and I can say that X is parallel to Z. Here's why. I know that X and Y are parallel. I know that Y and Z are parallel. We already went over this on the other one, on number 21 on the previous page. It is the transitive property of parallel lines. If two lines are parallel to the same line, Z and X both parallel to Y, and they're parallel to each other. Transitive property of parallel lines. Okay, moving on. 17, find the measure of the third angle, given the measure of two angles. Again, what we're using here is the triangle angle sum theorem. The triangle angle sum theorem says the interior angles of a triangle will always add up to 180 degrees. And we prove this, so we know it to be true. So we know that 75 plus 37 plus whatever the third angle is have to equal 180. So we know that 75 plus 37 is 112, plus the measure of angle 3 equals 180. We're going to subtract 112 from both sides, and we get the measure of angle 3 equals 68 degrees. If at any point that I'm going too fast or anything, here's a great thing. You're watching this on YouTube. You can stop, you can rewind, you can listen to it again. You can use these just to fall asleep to, since half you guys fall asleep the moment I start talking anyway. So they're beneficial on a whole lot of different levels. So let's look at number 19. 1 is an exterior angle, and 2 and 3 are its remote interior angles. Now, if I was going to draw this, it'd be like 1's over here and 2 and 3 are over here. Remember that this is equal to the sum of this. And again, we proved that. This is the exterior angle theorem. And it says that the exterior angle of a triangle is equal to the sum of the remote interior angles. So if we know that 2 and 3 are 37, we know that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. When we plug in 37 and 99, we get the measure of angle 1 equals 136. And we're on to the other review page. See how easy that was? 16 minutes. Albeit I only did half of them, but, whatever. So number 1, we're asked to solve for x. So here we know that these two lines are parallel. So what we want to do is we want to identify the relationship between those two angles. Again, look at that chart I gave you. You need to turn it sideways, turn the paper sideways so it matches up. When you do that, you'll see that those two lines, or those two angles, are alternate interior angles. And so if the lines are parallel, then alternate interior angles are congruent. So we know that 119 equals 3x plus 2. And then, algebra 1, solve for x. It's a two-step problem. Subtract 2, that's one step. Divide by 3, that's 2 steps. Not like the country two-step. That has nothing to do with mathematics. And on to number 3. Number 3, again, we have parallel lines and we have alternate exterior angles. Alternate exterior angles are also congruent. So we go 53 equals 6x plus 5. Subtract 5, and we get 48 equals 6x. Divide by 6, and we get x equals 8. Now, on number 5 forward, we not only have to solve for x, we have to figure out what the angle is, the value of the angle is. Now, here on number 5, we look at those two. If I were to look at the chart, that would be angles 5 and 6. I go, look through, and I see that they're a linear pair. Linear pair means they are supplementary. Supplementary means that they add up to 180. So in setting this up, I go 35x plus 24x plus 3 equals 180 degrees. I want to combine like terms, and I get 59x plus 3 equals 180. Subtract 3. 59x equals 177. Divide by 59. And I get x equals 3. Now, I'm not done yet. So if this was a test and I only put x equals 3, I'd only get partial credit. Even though that is correct, the problem doesn't ask me to solve for x. The problem asks me to solve for the value of the angle. And since the angle has an x in it, I need to solve for the x, go back, plug it back in. So I go 24 times 3 instead of 24 times x. Plus 3, that gives me 72 plus 3, or 75 degrees. Same general idea for number 7. Here we have alternate exterior angles. So instead of being complementary or supplementary here, they're congruent. So we go 10x or 11x plus 4 equals 10x plus 11. We're going to subtract 4 from both sides. That gives me 11x equals 10x plus 7. I'm going to subtract 10x from both sides, combine my like terms, and I get x equals 7. Again, not done. Need to go plug that 7 in right there. So I have 10 times 7 plus 11. That gives me 70 plus 11, or 81 degrees. And that's my final answer. On to number 9. Okay, so now we're looking at number 9. So from here on out, now these are the converses. Now, theoretically, they are asking a different question. Instead of saying that because the lines are parallel, what do the angles have to equal? They're asking, what do the angles have to equal in order to make the lines parallel? Mathematically speaking, algebraically speaking, it doesn't matter. We're still going to treat the problems using that chart, using those same relationships, and it just means something different. So instead of saying that because they're equal, this angle equals 55 degrees, we're saying that if this angle equals 55 degrees, then the lines are parallel. So here we're looking to make U and V parallel. So we look at those two angles, we see that they're corresponding, and corresponding angles must, if corresponding angles are congruent, then the lines are parallel. Hold on, I need to let my dog in. Rama, come here. Hey, Rama. Good girl, Ramiana. Come here. I'd ask her to say hi, but well, she's a dog and doesn't talk. So, number 11. We have, we identify the relationship between those two angles. That is same side interior, or consecutive interior, same thing. And we go, okay, the converse of the same side interior angle theorem says that if a transversal crosses two lines and same side interior angles are supplementary, then the lines are parallel. So what we're going to do is we're going to set this up just like we would if we said if they're parallel, what does x equal? We're going to do the same thing. 118 plus 17x, or 17 plus 5x equals 180. Combine like terms, we get 135 plus 5x equals 180. Subtract 135 from both sides. We get 5x equals 45. Divide both sides by 5. We get x equals 9. So instead of saying because u and v are parallel, x equals 9, we're saying if x equals 9, u and v are parallel. The math is the same, though. The algebra is the same. Geometry is a little bit different, but the algebra is the same. Moving on. Okay, so 13, 14, 15, and 16. What we're dealing with here is the triangle angle sum theorem. So we know that all three of those angles have to add up to 180 degrees. So that's what we do. We go angle A, 5x plus 5, plus angle 6x plus 4, plus angle 50 degrees equals 180 degrees. Combine like terms, 5x plus 6x is 11x. 50 plus 4 plus 5 is 59. We're going to subtract 59 and get 11x equals 121. Divide both sides by 11, and we get x equals 11. Now, we need to find the measure of angle A. Again, you need to make sure that you guys are reading the questions. So many times people are losing points. They get the right x, and then they just stop and move on. They don't go back and read the question. If it says, if it says solve for x, then solve for x, and you're done. If it says, solve for an angle measure or a distance or something like that, sometimes you're going to need to solve for x and then go back and plug it in, as is the case here. So we know measure of angle A equals 5x plus 5. We're going to plug that 11 back in. 5 times 11 plus 5 is 55 plus 5, or 60. Moving on to number 15. Same general idea. So we're going to go 15x plus 75 plus 10x plus 5 equals 180. Combine like terms, 15x plus 10x is 25x. How come you won't come over here? Come over here, Rama. My dog doesn't want to cuddle with me. It's a sad evening. And then we have 75 plus 5, or 80. 25 plus x plus 80 equals 180. And subtract 80 from both sides. We get 25x equals 4. Sorry, we get 25. I'm ahead of myself. X equals 100. Divide both sides by 25, and we get x equals 4. Again, we're not done yet. We need to solve for the measure of angle A. So we go 10 times 4 plus 5. Woo! Or 40 plus 5, or 45. Moving on. 17. These are a little bit tricky. So we're looking for that one. Well, we can't solve for that one, for the question mark, without knowing what this angle is. Angle, I'll call it x. Because if I know what angle x is, then I can use the triangle angle sum theorem to solve for the question mark. Now, how do I solve for angle x? Well, for angle x, I know that all three of those angles, 65 plus x plus what I'm going to call angle y, add up to 180. But I can't solve for x until I have y. What about y? I can't solve for y until... Wait, I can solve for y. I know that 80 plus 35 plus y has to equal 180. That is the... Woo! A little bit, wrong button. That is the triangle angle sum theorem. 35 plus 80 is 115. So I have 115 plus y equals 180. Or y equals 65 degrees. I know that x plus y plus 65 equals 180. So I can go 65 plus the measurement angle x equals 180. That gives me 130 plus the measurement angle x equals 180, or x equals 50 degrees. So I know y is 65, I know x is 50. So now that I know x is 50, I can go 50 plus 80 plus question mark equals 180 degrees. That gives me 130 plus question mark equals 180. Subtract 130 from both sides, and I get question mark equals 50. And that's my answer. 19, 20, and the like, they are they are exterior angle theorems. And remember, the exterior angle theorem says that the exterior angle of a triangle is equal to the sum of the remote interior angles. So that angle right there is equal to the sum of those two. And that's how we set up the problem. We go 14x minus 7 equals 101 plus 2x plus 12. We're going to combine like terms. So we have 14x minus 7 equals 2x plus 113. We're going to subtract 2x from both sides. So now we're going to start the process of combining like terms. We have 12x minus 7 equals 113. We're going to add 7 to both sides. We have 12x equals 120, or x equals 10. Okay, we're not done. We are asked to find the measure of angle FUT. So to figure out what angle that is, we start at F, go down to U, and go down to T. So it's that exterior angle. So we're going to plug 10 in. So we go negative 7 plus 14 times 10. That gives us negative 7 plus 140, or 140 minus 7 is a little bit easier, which is equal to 133 degrees. Number 21, same setup. We're going to go 26x. So that's GCD. That's what we're looking for. So when we find x, we're going to plug it. We're just going to multiply it by 26. We go 26x equals 9x plus 5 plus 80. Combine like terms, and we get 9x plus 85 equals 26x. Subtract 9x from both sides, and we get 17x equals 85. Divide both sides by 17, and we get x equals 5. Now, like I said at the beginning of this problem, we're going to take that 5, we're going to go back and multiply it by 26. So we have 26 times 5 equals 130. So the measure of angle GCD equals 130 degrees. Okay, now, moving on. The rest of these, 23 on, you're told to find both point slope and slope intercept. Remember, point slope. Okay, so I guess I talked about slope first. So parallel lines have the same slope. So if this line is parallel to y equals negative x minus 2, that means it has the same slope, negative 1. So remember, y minus y1 equals m times x minus x1. That's point slope. And slope intercept, we just solve for that y, and we get y equals mx plus b. Okay? So, slope intercept first. It goes through 5, negative 4, slope of negative 1. Y minus y1, which is negative 4, equals slope, negative 1, times x minus x1, that's our x value, 5. That gives me y plus 4 equals negative x, or negative x minus 5. Distribute that negative 1. So that right there, y plus 4 equals negative times x minus 5. That's point slope. So that's my first stopping point. Now to get to slope intercept, I want to solve for that y on the left-hand side. So I distribute my slope, and I get y plus 4 equals negative x plus 5. I'm going to subtract 4 from both sides, and I get y equals negative x plus 1. And that's my slope intercept. So those are my two answers. Point slope is y plus 4 equals negative x minus 5. And slope intercept is y equals negative x plus 1. Same idea for 25. If it's parallel to a line with a slope of negative 7/4, then it must also have a slope of negative 7/4, which means that I go y plus 2, remember, because that's y minus a negative 2. Y plus 2 equals negative 7/4 over x minus 4. That's my point slope. I then, to solve for slope intercept, I want to distribute my slope. Negative 7/4 times negative 4 gives me a plus 7. I'm going to subtract 2 from both sides, and I get y equals negative 7/4 x plus 5. And that is my slope intercept. Number 27, it's parallel to a line with a slope of negative 3/2. So we get y plus 3 equals negative 3/2 times x plus 2. Minus 2. And that's my point slope right there. Nothing more. Point slope has a point, it has my slope. I'm done. Now for slope intercept, I want to solve for y. So I go y plus 3 equals negative 3/2 x plus 3. Subtract 3 from both sides, and notice they cancel out. So this gives me y equals negative 3/2 x. Okay, now for the last bit, these are perpendicular. Now, perpendicular slopes are slightly different. They are not congruent, or they're not the same. They're not equal, like parallel lines. They're the negative reciprocal of each other. So here we have a slope of 1/2. So the perpendicular slope is going to be negative 2. And this is how we do that. Start off with 1/2. Now it's the negative reciprocal. So we take the reciprocal. The reciprocal means we flip it upside down. Negative, well, we just change the sign. Negative 2 over 1 equals negative 2. So we know the slope is negative 2. Plug it into point slope. Y plus 2 equals negative 2 times x plus 1. That gives me y plus 2 equals negative 2x minus 2. I subtract 2 from both sides, and I get y equals negative 2x minus 4. That's my point slope. That is my slope-intercept. Sorry about that. I'm going to skip 30 because that's something I want to go over in class, but 32. So we start off with negative 2/5. To get the negative reciprocal, we flip it over. We have 5 over negative 5/2, and then we change the sign. So we just have 5/2. Plug that into point slope. Y plus 1 equals 5/2 times x minus 3. It's a little bit trickier. So that's my point slope. Done. Now to solve for slope-intercept, we want to solve for y. So we go y plus 1. We're going to distribute that 5/2. If you want to ever turn that into 2.5 and do it like that, I'm fine with that. If you want to do decimals instead of fractions, I'm totally okay with that. We have y plus 1 equals 5 over 2x minus 5/2 times negative 3 gives me negative 15 over 2. I'm then going to subtract 1 from both sides. 1, so you know, negative 1 equals negative 2 over 2. So when I'm subtracting, I'm going to go negative 15/2 minus 2/2. And I end up with y equals 5/2 x minus 17 over 2. Now, if you did this on the calculator and we're using decimal points, it'd be y equals 2.5x minus 8.2, or 8.5, sorry. And that's totally okay. So hopefully this has been helpful. If you need anything, please ask for help. Email me, call me, whatever, don't care. My goal is for you to learn, and I'm willing to do what it takes to make that happen. Have a wonderful evening, everybody.